Luckily, yeah. All right, complex numbers. Complex numbers means the square root of -1 is equal to I. How to make your eye with a little curve on it. So, I or the square root of -1 is called an imaginary number. Imaginary numbers, that's what we're doing today. Alright, so properties of imaginary numbers. You do not have to memorize this, but I can tell it to you. What this means is that every imaginary number to a certain power means something. So I to the first power is just I to the second power is -1, I to the third power is -I, and I to the fourth power is 1. So it's like I1, I1. Luckily, I'll teach you how to use your calculator for all of this, but if you don't have a calculator, you'll use this. Our imaginary numbers are in patterns. So I to the 5th will be I again, and then I to the 6th is -1, -I, and then +1. The same thing for I to the 9th. You get I, -1, -I, and 1. In patterns of 4. So if they gave us 112, we could divide that 112 by 4, and then we can figure it out, but I'll show you an easier way. Alright. So this allows us to simplify negative square roots. The square root of -9, what's the square root of -9? Anybody? 3. But, okay, I have to bring this 9 out to be +3. And I bring my negative out to be I. Whenever you have a negative under your radical, you always, always, always have to bring it out. When it comes out, it becomes I. So for letter 5, or letter B, I have 5 plus the square root of -81. Alright, so I have 5 plus, that's not changing. The square root of 81 is what? Is 9. And what about my negative? It comes out in the imaginary number. So the square root of -81 converts to 9i. I cannot combine those two. Okay? 5 and 9i does not become 14i. Two different things. Same property as combining like terms. So for letter C, Jacob, what do we have here? The square root of -144. 12 what? Yep. 12 would be for the 144, that's the square root. The I would be for the negative. So on letter D, even if we don't have a perfect square, we still have to take that negative out. So I have -3 minus, and then I have the square root of -5. Is 5 a perfect square? No, I'm not even going to try to reduce that. But I bring my negative out to be I. The square root of 5 will stay. And that's my answer. I cannot simplify the square root of 5. But that I or the negative has to go. For letter E, what is the square root of 36? 6. There's no negative there, right? So we'll just leave it at 6. Now I have all numbers. I am not going to leave this as 5 plus 6. This this is 5 plus or minus 6, so let's split it up. What's 5 minus 6? Negative 1. And what's 5 plus 6? 11. So my answer here is negative 1 or 11. The reason why we can simplify this one is because I don't have an I. They just gave me 5 plus or minus the square root of 36. So I subtracted it and then I added it. Sorry, these projectors. Alright, letter F. I have 3 plus or minus, what's the square root of negative 64? 8 what? 8i. I cannot combine those any further. I cannot split those because of the I. Alright, so operations with complex numbers. What this means is that we treat our i's like x's. Okay, so think about when we have like 5 plus 3x. I'm not combining that to be 8x. Okay, that does not work. So we treat it like, you treat your i's like x's, meaning you want to combine like terms. Alright, so adding complex numbers. You add the real numbers together and you add the i's together. Example, A says 4 minus I plus 3 plus 3i. Imagine when you were in elementary school and we had like 2 plus 15 equals whatever. And sometimes it was easier to see like straight up and down, like vertically. You guys remember that? Like write it 2 different ways. That's what we're going to do here. I always write it 2 different ways just so I can see it better, because my signs get confusing. So I have 4 minus I plus 3 plus 3i. So I do my imaginary numbers first. So it's negative I plus 3i. Well, negative I is really negative 1 plus 3. What do we get? Negative 1 plus 3. 2. So we get 2i. And then I have positive 4 plus 3 for my real numbers. What's that? 7. So my answer is 7 plus 2i. Alright, for letter B, I have negative 2 plus 5i plus negative 3 minus 9i. I want to add my i's first. So I have 5 plus negative 9. What's 5 plus negative 9? So we have negative 4i. And then I have negative 2 plus negative 3. What do we get there? So negative 5 plus 4i is my answer. I'm good on A and B. Alright, now we have subtracting. So when we subtract complex numbers, we do the same thing. I'm going to stack them up. 4 minus I minus 3 plus 3i. To the side, I'm going to do my imaginary numbers first. So that's negative 1 minus positive 3. What do we get with negative 1 minus 3? For my imaginary numbers. Negative 1 minus 3? Negative 4i. Yeah, be careful with those signs. And then I have 4 minus 3. That would be 1. My answer here is 1 minus 4i. Alright, for letter B, we have negative 2 plus 5i minus negative 3 minus 9i. This is where my signs are very important. When I want to subtract my i's first, I have 5 minus negative 9. What was 5 minus negative 9? Double negative means I have to add them together. 14i. And then I have negative 2 minus negative 3. So once again, we have a double negative, so it becomes positive. So that is, should be 1, right? Positive 1? Yeah. 1 plus 14i. Alright, everyone get those down? Alright, multiplying complex numbers. We want to FOIL the two numbers, and simplify. Alright, so remember that I squared is equal to negative 1. That's important. I squared is equal to negative 1. So my example here, I have to FOIL this. FOIL means first, outer, inner, and last. So make sure you're paying attention so you don't miss a step. So if I multiply 4 times 3, I get 12. 4 times 3i, I get positive 12i. Inner means negative I times 3 gives me negative 3i. And last is negative 1 times positive 3i gives me negative 3i squared. I just FOILed out everything in those two parentheses. Alright, so because we treat our i's like x's, let's combine like terms. Nothing can combine with 12, but I have 12i minus 3i. What does that give me? 9. Yep. 9i minus 3. I squared is the same as what? Negative 1. So I'm going to go ahead and make that change. I squared is the same as negative 1. So I have 12 plus 9i. Negative 3 times negative 1 gives me positive 3. We're almost done. So now I have 12 and 3 that I can combine. So my answer is 15 plus 9i. So we FOILed it and we combined like terms. Letter B, 5 plus I squared. That does not mean that you distribute that 2 into the 5 into the I. We never do that. This means that we have 5 plus I times 5 plus I. And now I'm going to FOIL. 5 times 5 gives me 25. That's first. Outer 5 times I is positive. Positive 5i. Inner I times 5 is positive 5i. And last, I times I is I squared. Alright, nothing combines with my 25, so I bring it straight down. What's 5i plus 5i? 10i. R squared is really negative 1, right? So I'm just going to move that down as -1. I'm going to combine like terms. 25 minus 1 gives me 24. I still have 10i. All right, for my last expression for FOIL, I'm going to multiply these two. So first times first. So 6 times 6 is 36. Outer, -3 times 6 is -18i. Inner, 3i times 6 is +18i. And last, 3i times 3i is negative. Yeah. So that gives me -9i squared. My 36, there's nothing to combine with it, so I'll just bring it down. -18i plus 18i, what happens there? It just cancels out. 0. I didn't want to write it. And then I bring down my -9, but instead of I squared, I'm going to write -1. Type that all into your calculator. 36 minus 9 times -1. What do you get? What'd you get? 45. Yep. You should get 45. All right, that's the most work we're going to do today. Now I'm going to show you a shortcut. Okay. So, this 6 plus 3i and 6 minus 3i are called complex conjugates. The sign of the imaginary number changes. When multiplied together, the imaginary numbers will cancel out. What this means is that you're only looking at the sign before the imaginary number. So we're basically trying to figure out, when it says what are the complex conjugates, like what is the opposite of this guy? For letter A, I have 4 plus I, so the opposite is going to be 4 minus I, because that's the sign right before the imaginary number. When they're multiplied together, like B, I have -2i, so the opposite is going to be positive 2i. What about for C? I have -3 plus 5i. How do I change the sign before the imaginary number? Well, my -3 stays. What happens to the plus? So -3 minus 5i. Don't make that 3 positive. You're only changing the sign before the imaginary number. Then for D, I have 5 minus 3i. That changes to 5 plus 3i. All right, all good? All right, this is where the fun starts. Grab your calculators. So, complex numbers can be solved on the calculator, but we first have to get into the right mode. All right. All right, so in your calculator, I want you to hit mode. And you're going to go down to where it says real. Slide over to where it says A plus BI, hit enter. And then you can hit second mode again to quit and go back to your regular screen. In order to solve these problems the easy way, you have to be in A plus BI mode. If not, your calculator does not recognize imaginary numbers. All right? So everyone's in A plus BI? All right, so it says I is found by going on the calculator and hitting second decimal. If you hit second decimal, you'll see there's the I. So warnings for using I on the calculator. Each complex number needs to be in parentheses. And I, anything to like a power, hey Mr. Smith.
Good morning.
Anything to a power you have to put into I part. So we will talk about I part. Let's look at number 1. Okay, I don't have a complex number here. It's not the one in parentheses. It's just I to a power. You have to use I part. So let's hit math. Go over the number. Hit number 3 for I part. And then you're going to type in what you see. I to the power. You can raise it with the caret key that's over the division symbol. You're going to press -2. Slide over, close your parentheses. You should get -1. Anyone need help? It only works for that one, but probably you just do it without I parts and do it on it. Make sure you because using the I hours, different is, it's like around I part and then. All right, so we understand I part. -1. For number 2, we are typing in exactly what we see. That means everything in parentheses. So, what do I have? Parentheses, I plus 3, close parentheses, and then I minus 3. You guys get -10? You should get -10. Let's try the very last one. So 2 minus 2i, parentheses 2 minus 2i, minus, parentheses -3, plus 3i. You should get 5 minus 5i. You guys get that? So what our calculator is doing is saving you a lot of work doing all of this. Okay, if you want to do it by hand, go for it. I will never stop you. But why when your calculator can do it for you? Okay? If you're on your SOL or you're on the test and you forget, like I said, you can do it by hand, but just remember to make sure your calculator is in A plus B mode, and you're good to go. All right, so you guys are going to do the practice. There's 6 practice problems at the end of this page, and then you guys are going to do the 10 problems on the back. All right, so do those 16 problems, and then we'll come back, we'll check our answers, and life is good. So take about 10, 12 minutes. All right, so for number 1, you guys get 7 plus 3i. Number 2 is 6 minus I. Number 3 is 9 minus 9i. 4 is 2 plus 6i. 5 is -5 plus 5i. and 6 is negative I. Don't forget to do I part. Don't just type it in by itself. You have to go to math, number, I part. You guys get this right? All right, good. All right, some of these are tricky. I was trying to trick you. All right, so let's see here. Number 1, you should get C. Number 2, you should get B. You can put this in your calculator, or you could have done, this is 5i times 4i, which is 20i squared. The I squared becomes negative 1, so you get negative 20. Or you can just type it in. I'm going to kind of skip around. Number 6 is C. Number 7 is I. Let's have those 4. Okay. Number 3 is A. Number 4 is D. Number 5 is C. This one is tricky, okay? It was meant to be tricky, so I bet most of you got this one wrong. Because it's not asking what's the complex conjugate of 8 plus 2i. If they asked us that, your answer would be D. But they're just saying, what is the imaginary part of this number? And the imaginary part would be that guy. So it's 2i. Did we do 6 and 7 already? Yeah, right? All right, 8 is D. 9 is B. And 10 is D. How do we do? Good? All right, so you guys can actually